The National Electrical Code, or NEC, mandates motor overload protection in the control circuit when heaters are located in the power circuit for a critical reason to safeguard the motor against overload conditions, even in the event of heater failure. These heaters are strategically implemented to avert condensation from accumulating on the motor windings, which can lead to insulation breakdown and subsequent motor damage. However, heaters themselves are susceptible to failure, which can inadvertently contribute to motor overheating. Now, if the overload protection were solely situated in the power circuit, the motor would remain vulnerable and unprotected should these heaters fail to function correctly. By necessitating overload protection in the control circuit, the NEC ensures a comprehensive safety net for the motor. This arrangement guarantees that the motor remains shielded from overloads, regardless of whether the heaters are operating as intended or have experienced a malfunction. This dual-layer protection approach is essential for maintaining motor longevity, preventing costly repairs, and ensuring the safe operation of electrical systems. The control circuit overload protection operates independently of the power circuit, offering a fail-safe mechanism. This means that even if the heaters fail and draw excessive current, the control circuit protection will trip, preventing damage to the motor. This is particularly important in environments where motors are subjected to frequent starts and stops, or where the load on the motor varies significantly, as these conditions can increase the risk of overloads. The NEC requirements address various aspects of motor overload protection, including the sizing of overload relays, the type of protection required, and the location of the protection devices. For example, NEC Section 430.32 addresses motor overload protection and outlines requirements for different types of motors and applications. The specific requirements depend on factors such as the motor's horsepower rating, the type of motor, and the application in which the motor is used. Overload relays are commonly used to provide overload protection for motors. These relays are designed to trip when the motor draws excessive current for an extended period, thereby preventing the motor from overheating and being damaged. Overload relays come in various types, including thermal overload relays, magnetic overload relays, and electronic overload relays. Thermal overload relays use a bimetallic strip or a melting alloy to sense the motor current. When the current exceeds a certain level, the bimetallic strip bends or the melting alloy melts, causing the relay to trip. Magnetic overload relays use an electromagnet to sense the motor current. When the current exceeds a certain level, the electromagnet pulls in an armature, causing the relay to trip. Electronic overload relays use solid-state circuitry to sense the motor current. These relays offer more precise and reliable overload protection compared to thermal and magnetic overload relays. The NEC also specifies the location of overload protection devices. In general, overload protection devices must be located in the motor control circuit as close as practicable to the motor. This ensures that the motor is protected from overloads regardless of where the overload occurs in the circuit. The NEC also allows for the use of supplementary overload protection devices in addition to the primary overload protection device. These supplementary devices can be used to provide additional protection for the motor, particularly in applications where the risk of overload is high. Firstly, consider a scenario where a motor is used to drive a pump in a water treatment plant. If the pump becomes clogged, the motor may draw excessive current, leading to an overload condition. If the motor is only protected by overload protection in the power circuit, the motor may overheat and be damaged before the overload protection trips. However, if the motor is also protected by overload protection in the control circuit protection will trip, preventing damage to the motor. Secondly, imagine a situation where a motor is used to drive a conveyor belt in a manufacturing plant. If the conveyor belt becomes overloaded, the motor may draw excessive current, leading to an overload condition. Again, if the motor is only protected by overload protection in the power circuit, the motor may overheat and be damaged before the overload protection trips. However, if the motor is also protected by overload protection in the control circuit protection will trip, preventing damage to the motor. Thirdly, let us examine a case where a motor is used to drive a fan in a ventilation system. If the fan blades become obstructed, the motor may draw excessive current, leading to an overload condition. As before, if the motor is only protected by overload protection in the power circuit, the motor may overheat and be damaged before the overload protection trips. However, if the motor is also protected by overload protection in the control circuit protection will trip, preventing damage to the motor. The NEC requirement for control circuit overload protection enhances the overall safety and reliability of motor-driven equipment. By implementing this dual-layered protection scheme, the risk of motor damage, downtime, and potential safety hazards is significantly reduced. The control circuit overload protection is typically achieved using devices such as overload relays or motor protection circuit breakers specifically designed for control circuit applications. These devices are calibrated to trip at lower current levels compared to the main power circuit protection, providing a more sensitive response to overload conditions. This sensitivity is crucial for detecting and interrupting overloads caused by heater failures or other control circuit faults that may not be readily detected by the power circuit protection. Furthermore, the control circuit overload protection can be integrated with motor control systems to provide advanced monitoring and diagnostic capabilities. This allows for early detection of potential overload conditions, enabling proactive maintenance and preventing motor failures before they occur. These advanced systems can also provide valuable data on motor performance, allowing for optimization of motor operation and improved energy efficiency. The selection and application of control circuit overload protection devices must be carefully considered to ensure that they are appropriate for the specific motor and application. Factors such as the motor's full load current, service factor, and operating environment must be taken into account when selecting the appropriate overload protection device. The overload protection device must also be properly coordinated with the other protective devices in the motor control circuit to ensure that the system provides adequate protection against both overload and short circuit conditions. Proper installation and maintenance of control circuit overload protection devices are also essential for ensuring their continued effectiveness. Overload relays and circuit breakers should be regularly inspected and tested to verify that they are operating correctly. Any damaged or defective devices should be replaced immediately. The control circuit wiring should also be inspected regularly to ensure that it is in good condition and that there are no loose connections or other potential faults. Now to delve deeper into the specifics, let's consider some common scenarios and how the NEC addresses them. One common scenario is the use of motors in heating, ventilation, and air conditioning, or HVAC, systems. These motors are often subjected to varying loads and operating conditions, which can increase the risk of overloads. The NEC provides specific requirements for overload protection of motors used in HVAC systems, including requirements for the sizing of overload relays and the type of protection required. Another common scenario is the use of motors in industrial applications, such as manufacturing plants and processing facilities. These motors are often used to drive heavy machinery and equipment, and they are often subjected to harsh operating conditions. The NEC provides specific requirements for overload protection of motors used in industrial applications, including requirements for the use of motor protection circuit breakers and the coordination of overload protection devices with other protective devices in the system. It's essential to understand that the NEC requirements for motor overload protection are not static. They are constantly being updated and revised to reflect advances in technology and changes in industry practices. Therefore, it's crucial for electrical engineers and technicians to stay up to date on the latest NEC requirements to ensure that they are designing and installing electrical systems that meet the highest safety standards. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is adopted by many jurisdictions in the United States and around the world, and it serves as the foundation for electrical safety standards in many countries. The NEC requirements for motor overload protection are just one small part of this comprehensive document, but they are an essential part of ensuring the safe and reliable operation of electrical systems. By following the NEC requirements, electrical engineers and technicians can help to prevent motor damage, downtime, and potential safety hazards. They can also help to ensure that electrical systems are energy efficient and environmentally friendly. In addition to the NEC, there are other standards and guidelines that address motor overload protection. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the International Electrotechnical Commission, or IEC. These standards provide additional guidance on the design, installation, and maintenance of motor overload protection systems. One important aspect of motor overload protection is the coordination of overload protection devices with other protective devices in the system. This coordination is essential for ensuring that the system provides adequate protection against both overload and short-circuit conditions. The coordination of protective devices involves selecting devices with appropriate characteristics so that the overload protection device will trip before the short-circuit protection device trips in the event of an overload. This prevents the short-circuit protection device from tripping unnecessarily, which can disrupt the operation of the system. Another important aspect of motor overload protection is the selection of appropriate overload protection devices for the specific motor and application. The overload protection device must be sized correctly to protect the motor from overloads without tripping unnecessarily. The overload protection device must also be selected to withstand the operating conditions of the application, such as temperature, humidity, and vibration. Proper installation and maintenance of motor overload protection devices are also essential for ensuring their continued effectiveness. Overload relays and circuit breakers should be regularly inspected and tested to verify that they are operating correctly. Any damaged or defective devices should be replaced immediately. The motor control circuit wiring should also be inspected regularly to ensure that it is in good condition and that there are no loose connections or other potential faults. In summary, the NEC requires motor overload protection in the control circuit when heaters are located in the power circuit to provide a redundant layer of protection against motor overheating and damage. This requirement is based on the understanding that heaters can fail, and that if the overload protection is only in the power circuit, the motor will not be protected if the heaters fail. By requiring overload protection in the control circuit, the NEC ensures that the motor will be protected from overloads even if the heaters fail, enhancing overall safety and reliability. Understanding the NEC requirements and applying them correctly is essential for electrical engineers and technicians to ensure the safe and reliable operation of motor-driven equipment. This includes proper selection, installation, and maintenance of overload protection devices, as well as coordination with other protective devices in the system. Remember that the control circuit overload protection operates independently of the power circuit protection, providing a fail-safe mechanism. This redundancy ensures that the motor is protected even if the heaters fail and draw excessive current. The control circuit protection will trip, preventing damage to the motor. The NEC requirements are continuously evolving, so it is critical to stay updated on the latest revisions to ensure compliance and maintain the highest safety standards. By adhering to these guidelines, we can mitigate the risks associated with motor overloads and ensure the longevity and efficient operation of our electrical systems.